postulates and spatial angles. So this is all about parallel lines. So what is the definition? If you have two lines or segments or rays, as I mentioned, lines is without arrow. When you have segments or rays, there are arrow. There are not for segment there are no arrows, but rays there are arrow to show the line will go to which way. Okay, two lines are perpendicular if they meet to form congruent adjacent angle. Okay, so we need to recall theorem 1.4.1 that we already go through in topic 1. If two lines are perpendicular, then they meet to form right angles. So it's just the same. The theorem and the definition is almost the same. Okay, theorem 2.1.1, from a point not on a given line, there is exactly one line perpendicular to the given line. So you imagine that you have a line, and then there's another one point that is not in the line, not on the line. So the point can be anywhere, on top or on bottom. But the thing is, the point is not is not collinear with the 2 points. Okay, so if a point not on a given line, there is exactly one line perpendicular to the given line. So for you to make it easy for you to understand, let's look at this. Okay, this one is the snapshot from the textbook. Okay, if you can remember, if you can still remember, in the high school, I believe in Malaysia, in the high school, you learn how to draw this line. So when given that this is line L and you have point P, okay, and then you can use your, is it protector, I think, the protector, and then you put the sharp one at P, and then you draw lines, draw the curved line here, and then it will intersect at point A and point B, and then you put the sharp one at the point A, and then you can make a cross over here, and then you put the sharp one at point B, and then you can make a cross here. And then when you join the point P and the one that you cross here, namely point Q, then you will have one perpendicular line to line AB at point R. So this is basically explain the theorem mentioned here. So from a point not on a given line, there is exactly one line perpendicular to the given line. Okay, so this is like kind of the explanation. Okay, okay, now let's go to the parallel line. Just now we talk about perpendicular line. Now it's parallel line. Okay, parallel lines. Okay, parallel lines are lines in the same plane that does not intersect. So it will never intersect. Dia dekat, it's on the same plane. We will never meet each other. Okay, I think all of you already know about this. Okay, so let's look at postulate 2.1.1. Through a point not on a line, exactly one line is parallel to the given line. So for example, if we have a point on a plane, but it's not on a line, exactly one line is parallel to the given line. That means we can draw a line that go through the point and it's parallel to another given line. Okay, note that parallel lines are denoted by these symbols. Okay, these symbols. Okay, so suppose that we have A and B be two lines that are parallel to each other, then they are represented by this. So whenever you saw this, you can see A is parallel to B, or A and B are two parallel lines. Okay, next. Another term is transversal. Transversal is a line that intersects two or more other lines at distinct points where all of the lines lie in the same plane. So given a plane and you have lots of lines. Let's say the line is horizontal, and then we have one vertical line that crossing all the horizontal line. So that vertical line is called transversal line. You don't have to worry. I'll show you the example after this. Okay, so there are 5 things that we can get from the figure of transversal line. So first, there are 5 angles. First is interior angles, and then exterior angles. Lepas tu alternate interior angles, the corresponding angles, and alternate exterior angles. So 1, 2, 3, 4, 5. So what does that mean? Interior angles are angles that are formed between 2 lines. So any angles between 2 lines, 2 horizontal lines is the interior angles. Exterior angles are angles formed outside the lines. So it's like vice versa of this. Corresponding angles for a line are 2 angles that lie in the same relative position, such as above, left, or below, right. Okay, and then it must be in pairs. And then alternative interior angles are 2 interior angles that have different vertices and lie on the opposite side of the transversal. That means this one also must be in pairs. Same goes to the alternate exterior angles must be in pair are 2 exterior angles that have different vertices and lie on the opposite sides of transversal. Okay, let's look at this example here. So we have line R and line S over here. These 2 lines don't have to be parallel. It can be any line and go towards any direction. And then we have one line T. This line T is a transversal for line R and S. Okay, this is what I'm trying to say. So this example is only a transversal line that cross 2 lines only. Okay, but it can be more. Okay, so we have theta 1 here, theta 2, theta 3, 4, 5, 6, 7, and 8. So we have, remember, we have 5 different name of angles that we can describe from this diagram. So first is interior angle. And interior angles that are formed between R and S. So this is R and this is S. So this is where the interior are. Okay, so the interior angles are okay, theta 3, theta 4, theta 5, and theta 6 will be the interior angles. While for the exterior angles that are formed outside the 2 lines, so they will be theta 1, theta 2, theta 7, and theta 8. So when you combine the union of these 2 interior and exterior angle will give you all the angles for this diagram. Okay. Okay. Now for the corresponding angles, let me just show you this way. Nampak kan? Okay. For corresponding angles, it must be in pairs. So theta 1 and theta 5, because okay, let's delete this one. Okay, and then have this. Oh. Okay, first we look at theta 1 and theta 5. Okay. Theta 1 and theta 5. Each angle is above the line and to the left of the transversal. So both have the same criteria to the transversal. Above the line, above the R and S line, and towards the left of the transversal. And then we have theta 3 and theta 7. So each angle is below the line and to the left of transversal. And then we have theta 2. Okay, oops. We have theta 2 and theta 4. Okay. These two theta 2 and theta 6. Each angle is above the line and to the right of the transversal. And then next we have theta 4 and lastly theta 8. Each angle is below the line and to the right of the transversal. So altogether, since we have 8 angles, we have 4 pairs of corresponding angles. Okay, now let's look at the fourth one, which is the alternate interior angle, and the fifth one is alternate exterior angles. Both are also almost the same with the number 1 and number 2 type of angles. Okay, but what is alternate interior angles? It will be given as, okay, theta 3 and theta 6. Okay, let's show it here. Theta 3 and theta 6 over here. Okay. Because when it says interior angles, it must the related angle must be the one that interior angle, because just now we say about interior angles, right? Which is we have theta 3, theta 4, theta 5, and theta 6. And the alternate interior angle, it must be in pair. It becomes between theta 3 and theta 6. And the other pair will be theta 4 and theta 5. And look at the name, it says alternate. So you can see like it's kind of the opposite one. The opposite of theta 5 is theta 4 over here. And then given that alternate exterior, before this we look at the interior, now we look at the exterior part. So if you have theta 1 over here, what will be the exterior? Alternate exterior will be theta 8. Okay. And then if you are talking about theta 2 over here, then the punya pair will be theta 7. Okay, so you have theta 1 and theta 8, theta 2 and theta 7. Okay. Do you have any other question? Any question? No?
No.
Okay. Good. Okay. Oh, kejap ya. Kejap. Nanti dia hilang. Okay, let's go through the postulates. Okay. Postulate 2.1.2. You can add this one in your list of postulates. If two parallel lines are cut by a transversal, okay, all this, okay, this one postulate and these two theorems start with if two parallel lines are cut by a transversal. Okay, you can see all the same. What the difference is the next statement. Then the pairs of corresponding angles are congruent. Pairs of corresponding angles are congruent. Ini pula. Okay. Mantap lah. Okay. Pairs of corresponding angles are congruent. When we say congruent, they have the same measures. And then, if two parallel, theorem 2.1.2, if two parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. And then this one, same, but this is the pairs of the alternate exterior angles are congruent. So let's look at this part. Okay. So can anyone tell me what is the corresponding angles? So there are corresponding, we have 8 angles over here. So when we talk about corresponding angle, it must be in pairs. So we have 4 pairs of corresponding angles. Can someone tell me the first pair? Anyone? The first pair of the corresponding angles? 1 and 5. Good. So we have 1 and 5. Next, anyone? Second pair?
3, 7.
3 and 7. Good job. 3 and 7. Next,
2 and 6.
2 and 6. Good. Okay, last one.
4 and 8.
4 and
8.
4 and 8. Well done. So we have 1, 2, 3, 4 pairs. Okay. Okay, next, let's look at the alternate exterior angle. Alternate interior angle. It must be the angles in between line L and line M. So, can anyone give me the first pair? We should have 2 pairs because we have 4 angles over here. We should have 2 pairs. Okay, the first angle is, anyone?
3,
3, 6.
Good. 3 and 6. Okay, the next one? The last one?
4, 5.
4, 5. Good. Okay, now last one. Kita tengok dekat alternate exterior angle where we're gonna look at the 4 angles that is outside the line L and M. So the first pair is, anyone?
1 and 8.
Okay, 1 and 8. Okay, second pair is
2 and 7.
7. Good. Okay, seems like every one of you understand this postulate and these 2 theorems. Okay, let's look, because we have 5 kan, kita ada 5 angles. Let's look another 2. So theorem 2.1.4, if 2 parallel lines are cut by a transversal, then the pairs of interior angles on the same side of the transversal are supplementary. So the difference between this one and before one, the one before, is this one the angles are supplementary. While before this, what we have all are congruents, kan? So it's a little bit different. So this one is congruent. When we talk about corresponding angles, alternate interior angles and alternate exterior angles, the pairs are congruent. While when we talk about the first one is the interior angles and the second one is about the exterior, the pairs of exterior angles on the same side. Okay, sebab, okay, as you can remember, interior and also exterior angles is not coming with pairs. It just like for example, this one, the interior angles is 3, 4, 5, 6. It's not 3 and 4, 5 and 6. But now we talk about pairs of interior angle on the same side. So, kat mana kita nak cakap pasal pairs yang on the same side? Kita tengok kat sini. Anyone? Okay, first sekejap. I need to highlight this
5.
one. Okay. Yang mana? Kalau interior, pair dia?
3, 5.
3 and 5. Yep. 3 and 5. Yang first. So, 3 and 5 is on the same side. Then, 3 are supplementary angle of 5. So, the next pair will be?
4 and 6.
Good. Okay. 4 and 6. Okay. How about the exterior angle? It's quite easy kan? Okay. Tapi nak jugalah korang yang jawab. What is the first pair for the exterior angles that when we sum, it will become equals to 180. Remember, supplementary, the additional, the summation of 2 angles become 180 degrees, right? So the first pair of exterior angles of the same side? 1 and 7. Good. Okay, the second pairs?
2 and 8.
2 and 8. Good job. So when we talk about side, it's the side we are based on the transversal line. The transversal line here is V. When we talk about the same side, it will be either the the left side of the transversal line or the right side of the transversal line. So that's why we got 1 and 7 because both are on the left side of the transversal line and 2 and 8 on the right side. Same goes to the interior lah. Okay. Next. Kita tengok dekat example Okay. So this one is parallel line, two parallel line B and C. Okay, because before this kita tak consider parallel line. Sekejap Okay, betul. So now we consider two parallel line. Okay, B and C. And then we have A is the transversal line for B and C kan. So yang ni symbol apa? Anyone? Okay, parallel. Good. Yang ni parallel. Okay. Sekejap. Mari tengok. Kata ni silap. Parallel tapi A ni tak parallel dengan ni kan? You are talking about is it this one? No. I think this one silap ni, B and C ni. Okay, yang ni B and C lah. Nanti korang betulkan. So this is B parallel to C. And A is the transversal line, betul tak? Transversal line. And then we know this one, theta 1 here is 117. So we need to find the other remaining angles. So from one angles here, we can actually find all the remaining 7 angles over here. So first what we do, we know that theta 2 is equal to 63 degrees since theta 1 and theta 2 are supplementary angles. So 180 minus 170, we got 63. Same goes to theta 3 because since theta 1 and theta 3 are supplementary angles, 1 and 3 here. Okay, are supplementary angles, so we got 63 degrees. So we already got theta 1, theta 2, and theta 3. Next, theta 4. Theta 4 is 117 degrees since theta 1 and theta 4 are vertical angles. Okay, yang ni kita tak go lagi the type of angles yang kita baru discuss today. Okay, and then theta 5 here, we got 117 degrees since theta 1 and theta 5 are corresponding angles. So you remember when we talk about corresponding angles, okay, when we talk about corresponding, tak boleh. When we talk about the corresponding angles, the two angles are congruent kan. When congruent, the measure are the same. So that's why 117 degrees. For theta 6 here, we got 63 degrees because theta 2 and theta 6 are corresponding angles also. So it's a congruent and same in measure. Theta 7 here, you got 60 degrees since theta 2 and theta 7 are alternate exterior angles. But actually you can also go to the definition of the, not definition, the theorem of interior angle. Kan tadi kita ada juga supplementary kan. Interior, the pair of two interior angles two same side interior angles are supplementaries, but we can also go to a theorem about alternate exterior angles. And then theta 8 equals to 117 degrees since theta 1 and theta 1 and theta 8 are alternate exterior angles. Okay. Theta 1. Kenapa yang ni jadi ni? Okay. So let's look at example 3. AC and DF are two parallel lines with transversal T. Prove that theta 1 here and theta 3 are supplementary. So kita nak prove this one lah. We know that theta 1 and theta 3 is interior. By looking at the diagram, we know it's interior. Dia same side kan. So first, when we want to draw the solution, we know that the given is AC and DF is a parallel line with transversal T, and we need to prove theta 1 and theta 3 are supplementary, which is theta 1 plus theta 3 equals to 180 degrees. So what we're gonna do here, let's hope that, oops, sorry. Oh, tak. Back. Okay, so given parallel, transversal T, and then using the theorem 2.1.2, if two parallel lines are cut by a transversal, then the pairs of the alternate interior angles are congruent. So theta 1 is congruent to theta 2 here. Okay, theta 1 congruent theta 2. So, ni alternate interior kan? Okay, so when the two angles are congruent, then their measure are equal. And then we know that DEF is a straight line. Where is DEF? Right here. DEF is a straight line having a straight angle. So DEF is 180 degrees. So the reason is straight angle is an angle having 180 degrees measure. And then we know that using the angle addition postulate, theta 2 and plus theta 3 equals to 180 degrees. And then we use substitution. We substitute DEF equals to 180 degrees here. See, when I talk about this one, it's going to talk about the step before. It's not talking about the next step, the step that we're going to use for to get the following step. So 7, from the substitution, we know that theta 1 equals to theta 2. So from theta 2 here, we substitute equals to theta 1 over here. So the reason is substitution. When it's equal to 180 degrees, it shows us that theta 1 and theta 3 are supplementary. So it's proven. Okay, so for those who are still confused, you don't have to worry because I also have a lot of confusion before. You try to look all lots of example in the website and try to read and like explain it to you. Before you try by yourself, maybe you can just read the answer because the answer that they have and try to make you understand how they answer that. So that maybe you boleh dah nampak lah dia punya flow, how to write the reasons. Okay? Okay. Now let's look at example 4. Okay. So we have two lines here, R and S, and there's a transversal line, which is T, and we know that theta 3 over here is 4x plus y, theta 5 over here is, kat sini, is 6x plus 5y, and theta 6 over here is 5x minus 2y. Okay, so what kind of information that we have? Kenapa dia? Okay, so we know theta 1. Sorry, bukan theta 1, theta 3 kan. Theta 3 over here. And then we know theta 5 over here. And then we know theta 6 over here. Okay, so from here you know all these three angles are interior. And we know about this one and we know about this theta 3 and theta 6. Okay, so let's go through. Okay, what is the relationship between theta 3 and theta 6? Anyone? What angle is that? Ingat tak? Theta 3 and theta 6 are pair of what angle?
Alternate interior angle.
Okay, good. Alternate interior angle. So bila kita kata
Alternate interior.
okay, right. Alternate interior angles. We know that theta 3 and theta 6 are alternate interior angles. And using the theorem 2.1.2, theta 3 and theta 6 are congruent. When you say congruent, that means the angles have the same measure. So we can have theta 3 equals to theta 6. So theta 3 is 4x plus y, theta 6 is 5x minus 2y. And then you can solve this one, you know how to do it. And you got first equation which is negative x plus 3y equals to 0. Next, we need to find the second equation because we want to solve for x and y. We're going to have one equation only. So we have theta 3 and 5. Theta 3 and 5. Okay, jawapan dah ada kat bawah. So tak payah tanya lah. Okay. Theta 3 and 5 are two interior angles, pair of interior angles on the same side. Okay, because 3 and 5 on the left side of interior angle. If two lines are cut by a transversal, ni theorem 2.1.4, the pairs of interior angles on the same side of the transversal are supplementary. When we talk about supplementary, the summation of both angles equals to 180 degrees. So we have theta 3 plus theta 5 equals to 180 degrees. So we have theta 3 4x plus y plus theta 5 6x plus 5y. And then we try to solve it, and then we got 5x plus 3y equals to 90. Okay. Okay. So we use the simultaneous equation to solve these two equations. Minus negative x plus 3y, and then we minus 5x plus 3y equals to 90, and then we got x equals to 15. We put x equal to 15 into the first equation, and we have y equals to 5. Okay. As for now, ada question tak? Saya nak minum air jap. Kita rehat 5 minit, ada question, bagi tahu. Sekejap pukul 3 kita continue, boleh minum air kejap, nak pergi toilet ke. And kalau ada question boleh tanya dalam masa 5 minit ni. Sampai pukul 3 nanti. Ada question tak? Anyone boleh tak bagi tahu saya, in case kalau you punya connection tak okay, macam ni you masuk balik? You masuk balik guna My Guru ke ataupun macam mana?
Doktor tanya apa tadi?
Kalau contohnya you macam line tak okay kan, you terkeluar ke apa kan, you disconnected from the Google Meet. So normally you masuk balik, you guna My Guru punya link juga ke ataupun macam mana?
Biasanya boleh tekan rejoin je.
Rejoin je, tak perlu pergi dekat My Guru tu lah.
Tak perlu.
Okay, sebab saya nak buat different link untuk group D sebab takut nanti jadi macam last week tercombine pula at the end tu.
Okay. Dia boleh rejoin je.
Okay, thank you Nesha.
Okay, doktor.
Doctor,
Yep.
for that one, it should be theta 5 plus theta 6, right?
Yang mana ya? Yang
Itu interior punya itu, the interior number on the same side.
oh, okay. Oh, sebab dia buat ni kejap Sorry because sebab kita guna slide Dr. Surya ni sebenarnya. So, sebab dia buat ni. Kalau supplementary theta 3 kan 3 5 supplementary. Sebab kalau kita discuss same sides tadi 3 5 tu memang this side kan sebenarnya kan. Tapi dekat dalam ni kita guna 4x 6x. Oh, okay. Memang betul lah 3 and 5 because yang 5 dengan 6 ni boleh juga kalau you nak guna 5 dengan 6 sebenarnya. Tapi yang kita nak dapatkan the second equation, we use 3 and 5 sebab kita nak guna theorem yang about the pairs of interior angle with the same side. Kalau interior angle same side, it's 3 and 5 because it's on the left side of transversal. So, based on the theorem, ni, the pair of interior angles on the same side are supplementary. But if you want to use 5 and 6, also can. Tapi 5 and 6 ni bukannya theorem yang ni lah. Bukan theorem 2.1.4 ni. Faham tak maksud saya?
Okay, faham doktor.
Okay, kalau 5 and 6 ni kita boleh kata definition, is it a definition of supplementary angles lah. Because we have lines and then kita ada ni kan, so the addition, the summation of two angles in the straight line will become equals to 180 degrees. Kat sini lah untuk supplementary. So you boleh je untuk second equation tu you buat theta 5 and theta 6 equals to theta 5 plus theta 6 equal to 180 degrees. I think you're gonna get the same answer jugalah. So that means you will have different set of answer punya step lah. But the at the end you got the same x and the same y. Okay. I think ada tak lagi yang pergi toilet? Tak ada kan? Okay. Kita continue. Sekejap saya delete ni. Okay. Okay. So before this we have the postulate 2.1.2 and then we have ada 4 theorem 2.1.3 until 2.1.5 where that theorem, all that 4 theorems and 1 postulate all start with like kita establish dia punya angle relationship dia. So we start with if two parallel lines are and then kita will have then dia adalah what angle. Okay, but then in this part, in the following 5 theorems, kita nak prove that rather than kita nak establish dia punya angle relationship, tapi kita nak prove that the two lines are parallel. Okay, so boleh tengok dia punya differentiate, we can differentiate yang theorem yang sebelum ni and this set of theorems where they previously kita say if there are two parallel lines, then they are what type of angle. But the next 5 theorems ni will be if what type of angle something relationship, then these lines are parallel. So kita nak prove benda tu adalah two lines which are parallel. So why we come up with this kind of theorem, sedangkan kita tengok kalau as we can remember the characteristic of good definition, we have the last characteristic will be reversible, isn't it? This one like kind of reversible. Tapi why we need to come up with this theorem, sedangkan kita dah ada theorem tu, kita boleh just reversible je lah kan. The thing is because previously if we don't come up with that theorem, the only method that we have to prove parallel lines only based on the definition of parallel line. So whenever we have we want to prove anything that related to parallel line, we will go back to the definition of parallel line. But we cannot go back, we cannot relate to the angle. We can relate to the list of theorems that we have just now. But the thing is, list of theorem tu dia try to prove the angle relationship. So now we talk the other way around. The theorem is the other way around because we want to prove these lines are parallel. So in the next 5 theorems, you will see the second statement or the last statement will be then these lines are parallel. Okay, so let's look at the first theorem, 2.1.6. If two lines are cut by a transversal so that two corresponding angles are congruent. Okay, boleh nampak kat sini talking, dia establish angles dulu dekat first statement. Two corresponding angles are congruent. Oops. So dia punya if, dia kan ada if then kan. If two corresponding angles are congruent, then these lines are parallel. So this yang the same lah. The second statement same je. These lines are parallel. So kalau you go back to the postulate 2.1.2, they are talking about if two parallel lines are cut by a transversal. Kan? This one, tak boleh sebab saya add kemudian. If two parallel lines are cut by a transversal, kita talk about the parallel lines first. Kita define, kita statekan parallel lines first, and then it shows or it prove, then the pairs of corresponding angles are congruent. You boleh nampak The first statement kita cakap pasal parallel line. The second statement we talk about what the angle relationship yang kita establish because of the two parallel line. But this one, we talk about the angles first. If two corresponding angles are congruent, then these lines are parallel. So it's just a reversible je lah. Okay, let's look at the second example. Okay, yang ni 2 example je, but you can check for the 2.1 and 8.8 and the rest. So 2.1.7, if two lines are cut by a transversal so that two, so that two alternate interior angles are congruent, then these lines are parallel. Okay, so first statement, two alternate interior angles are congruent. So kalau kita tengok dekat theorem 2.1.2, if we go back, if two parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. You can see kan? Dia the other way around. First we talk parallel and then alternate interior angles are congruent. But this one, we talk about alternate interior angles are congruent first and then these lines are parallel. Okay, you can check yourself for 2.1.8. If two lines are cut by a transversal, I underline je, by a transversal so that two alternate exterior angles are congruent, then these lines are parallel. So sama je. If you know the concept, you tahulah. So that means if you got the question later and you need to prove using the 2-column proving method, and the step involved are talking about the angle, but you want to show that it's a parallel, then you can use this theorem. But when you are given the information of it's a parallel and you want to show that what is the corresponding angles, then you use the theorem yang before this lah, 2.1.2 semua tu kan. Okay, the next two. Point 9, if two lines are cut by transversal, that two interior angles on the same side of the transversal are supplementary, then these lines are parallel. Okay, sama juga dengan 2.1.10. Sekejap ada student ni. Okay, some of you have problem with the lines Tak apa, it's quite easy this part. Nanti kalau siapa yang next ada yang terkeluar, disconnected from the Google Meet, you can try to learn by yourself. Nanti saya summarizekan dekat ni sampai mana kita belajar hari ni. If two lines are cut by a transversal so that two exterior angles on the same side of the transversal are supplementary, then these lines are parallel. Same ni pun you boleh compare dengan previous theorem. Okay, now we have theorem 2.1.11. This one we don't, it's not a reversible from previous theorem, but this kind of like a new theorem. Okay, new introduction for the theorem. If two lines are each parallel to a third line, then these lines are parallel to each other. So given that we have two lines, and line 1 is parallel to the third line, line 2 is parallel to the third line, then these lines are parallel to each other. It's just easy. Even this one is, it's like postulate. It's quite direct forward. Tapi maybe it's we can argue this statement, so they have proof for this theorem. Okay, for theorem 2.1.12, I want you to look at these two because these two theorems have almost the same statement, but it's a little bit different. If two coplanar lines, this one if two lines, if two coplanar lines, okay, this is the difference, are each, this one we talk about perpendicular to a third line. Just now we talk about parallel, this one we talk about perpendicular. Okay. Allah. Perpendicular to a third line, then these lines are parallel to each other. So this one we talk about parallel, this one we talk about perpendicular, and this one involve three lines, this one also involve three lines. But when we talk about these three lines, perpendicular and this line are parallel to each other, which means that if you have line 1 and line 2, and each line perpendicular to a third line. So line 1 perpendicular to line 3, line 2 perpendicular to line 3, then these lines are parallel to each other. That means line 1 and line 2 are parallel to each other. So what we talk about coplanar lines is lines belonging to the same plane are called coplanar lines, in case you forget about it. So this is like, for example, you have line 1, line 2, and this is the third line. So if this one is perpendicular to this one, and this one perpendicular to this one, so we can say that these two lines is parallel to each other. So this one we can say that this statement is true even if the three lines described are not coplanar. Okay, that means all these three lines doesn't have to be in the same plane. But this one, it cannot be true if not if all three lines is not on the same plane. That's why we have coplanar here. When we talk about coplanar, that means it must be on the same plane. But when we talk about the third line, which is the perpendicular, obviously only one point yang on the plane kan, on the same plane with the two lines, but the whole perpendicular, the whole line 3 is not on the same plane with the two lines here. Okay. Okay. I think that's all we're going to learn today. So I hope you can understand what we have learned. We have we have already established 5 different angles given that corresponding angles. And you need to remember that corresponding angles must have, if you have 8 angles, you have 4 pairs of angles, 4 pairs of corresponding angles. It must be in pairs, and then we have interior angle, exterior angle, plus we have alternate interior angle and alternate exterior angles. You can practice yourself because sometimes it's quite confused. You try to draw and try to do it by yourself and try to check back the answer from the slide that I have over here. And then remember that we have the first 4 theorems, including the first postulate here, where we try to establish what are the angle relationship given that the 2 lines are parallel. And then just now we already discussed the 5 theorem, which is the reversible side, the reversible statement from the previous one, where we want to establish the lines are parallel given what is the relationship of the angles. And then we have these 2 theorem here where we talk about the third line, when we introduce the third line about whether it's parallel or not with the 2 lines. And it will be parallel if it's parallel to one line, it's going to be parallel to another line. And then this one, we talk about the coplanar line and about perpendicular to a third line. And these 2 lines will be parallel to each other. So to test your understanding, you can try to solve exercise 2.1 here. So we have question 1. We consider this diagram. We have line L and M. And I think it's almost the same diagram as before. Theta 1, 2, 3, 4, 5, 6, 7, 8 dekat sini Don't get confused. Before this we have 5 here, theta 6 here, 7, 8. But now we don't have theta 8 shown in the diagram. But if you want to tell what is the theta 8, you can have this one as a theta 8. So L and M is parallel to each other. Transversal T. This one is theta 1 equals to 4x plus 2. Nampak kan? 4x plus 2 and theta 6 over here. 4x minus 2, we need to find what is the value of x and what is the value of theta 5. So you can solve lah. So since it's involve x, dia senang lah. Before this example, kita ada x dengan y kan. So in this example, we only have x. So you just solve for x, cari x and then find theta 5. So tengoklah. So whenever you got this equation, this kind of question, check what is the given. Theta 1 over here and theta 6 over here. Kat sini apa? What is the relationship between theta 1 and theta 6? Saya bagi, dah bagi hint ni untuk answer. Anyone can give me the relationship of angle theta 1 and angle theta 6?
Alternative interior.
Alternate? Exterior kan?
Yes.
Yes.
Alternate exterior angles. Nanti carilah. Look for the theorem talking about alternate exterior angles. What does it say about the angles? Then you can solve for this. Okay, and then you need to find theta 5. So you also have, you can use from theta also, you can use from theta 1. Theta 1 and theta 5 ni corresponding kan? Dah bagi jawapan dah tu. And also you can use theta 6 juga actually because theta 6 and theta 5 are supplementary. Okay, number 2, for the following diagram, nampak looks complicated. It just like the other way around of the diagram je. Sebab before this we have transversal go up kan. Ini go horizontal. So for the following diagram, MN parallel with transversal K here. So we have theta 1, 2, 3, 4, 5, 6, 7, 8. So you got the information for theta 1, theta 2 and theta 8. Then you need to find x, y and theta 8. That means after you find x and y, you put in this third given equation and then you got the value of theta 8. Easy ni. Okay, number 3. So you have M and N is parallel and transversal K. Okay, this one you need to use the 2-column proving method. Prove that theta 2, mana dia tahu? Okay, this theta 2 and theta 7 are congruent. So what theorem say about theta 2 and theta 7? Because sometimes when you do the proving, you can do back ways kan. I mean from what you want to prove, you go macam terbalik lah, back way kan. What is step before that, whatever easy for you, then you can do. Okay, honestly for me, I like to write the statement first and then baru I write dia punya reasons. But sometimes you can adjust. It doesn't mean that when you write statement, bila you nak write reason tu, it will be just translate into reason. Sometimes you think like, oh, it does macam flow dia doesn't look really flowy. You can adjust a little bit. But it's a good that you have a statement lah. Okay. Number 4. So you have this diagram here, 2 lines here. Okay. It doesn't label the line, but from the question we know that L parallel to M. So here L and M is parallel. This is line L, M. So we have theta value for theta 4, theta 5, 2, 7. Oh, okay. Because it's a different. From question 4, we have 3 sets. Set A, given theta 4 and theta 5. Set B, theta 2 and theta 7. Set C, theta 3 and theta 5. So you need to find the value of x. Okay. So 4 ni ada 3 different x lah. Okay. And lastly, number 5, conduct a formal proof to prove that if 2 parallel lines are cut by a transversal, then the corresponding angles are congruent. Yang ni postulate 2.1.2 kot. Postulate 2.1.2 ke? Rasanya. So you need to find, okay, look at the topic 1 towards the end punya page tu ada tunjuk macam mana nak conduct formal proof kan. Try using that one and try to prove lah. Okay, so ada 5 question. You can answer and then we will discuss the answer on Friday class. Okay, Friday class, sebab Friday class we have only 1 hour class, so we will use that 1 hour time to discuss our question, our exercise. So we already finished the first part of the topic 2. The second part, because we have time, I'll just go through. The second part, we will go about polygons. We will talk about polygons. We already go through the shapes and everything. What are some of the polygons we can we have over here, and then some theorem. We're going to look here. Okay, you boleh tengok lah this slide before class next Monday. Oh, it's going to be hard because I'm going to go back to balik kampung for Deepavali. Okay, they have corollary here. And then we have exercise. Okay. This one. And dah tak banyak pun ni. Sikit je. This one, transformation, reflection. This is like kind of recap what you already learned during your high school. Then ada sikit indirect proof. Okay. Oh, okay. So that means tak ada exercise kat sini. Ada exercise sikit je ni. So, exercise dia pun macam senang je. So, for the next week, we're gonna go to the second half and then you can do the exercise. And then nanti probably on Friday next week, we're gonna do like simple quiz je lah macam last week. So sebab kita dah habis topik tu next week kan. Nanti bolehlah kita buat during class so that it will be much more fair for people yang ni lah. Okay? Ada question tak? For today punya class? Anyone? Ada question? Ni apa orang? Oh, ramai lagi. Ada question? Tak ada
No.
No.
No, Doctor.
Okay, so now 3:25. about 3:25, we can finish our class today. We're gonna see you on Friday. Don't forget to answer the exercise. Yeah, I think it's quite a lot. Okay, but it's not that hard. Maybe number 4 and number 5 a little bit hard. Okay, and we're gonna discuss on Friday. Okay?
Okay, doctor.
Okay, thank you everyone.
Thank you, doctor.
Thank you, Doctor.